Good morning, everyone. I am Christine Xu. This is my first time in TC, and I'm so excited to meet all of you. I am a senior software engineer at Tableau. I have been working on Tableau Prep for 1.5 years. My primary focus area is performance. I always like to get instant response. For example, when I am booking my trip online, I'd like to get instant confirmation after I click the book button. I think the performance is a very important factor to delight our customers like you.
Good morning, everyone. I'm Rupinder Jawanda, a senior product manager on the prep team. This is my 4th TC, and I love coming here. It's my favorite part of my job. Meeting with customers and hearing their experiences with the product and what's going well and what's not, it's really interesting to me as a product manager, so I can go back to work and kind of fix those things that aren't going well. So today's talk is focused on how to optimize your flows in Prep Builder. Now, I know performance can be a bit of a dry topic, but we all know it's super important, and that's why you're all here today. We think of performance a lot in our everyday lives as well. Me, I'm the kind of person who sits in the school drop-off line when I'm taking my kids in the morning, and I'm thinking, gosh, if we had a go-ahead green light or a longer curb, we could get so many more kids in the school faster. That's me. That's what I think about. I think about performance a lot. And today we want to help you maximize your flow performance and your experience with prep. We're going to concentrate on 4 main areas today. The first is an architecture overview. We're going to discuss a high-level view of the architecture so we can show you where we cache the input nodes and the joins, and you can see how caching can help improve performance. Second, we'll delve into the factors that impact performance for the flow. These factors include things like the amount of data you're bringing in, the databases you connect to, the sample size, and the complexity of the flow. Third, we're going to cover how you can run your flows directly from the command line without having to go into the Prep UI to run them. And lastly, we're going to leave time at the end for additional questions. So if anything comes up during the presentation, just jot down some notes, and then you can bring up the issues at the end, and we'll have plenty of time.
I would like to introduce some concepts before we get to architecture. Let's imagine that you have opened the Prep Builder and start building a flow. The moment that you start importing input data and building all different steps, such as clean, filter, join, union, aggregation, you are in what we call interactive mode. Once you finish your flow building exercise, the moment that you click on the small triangle to run the entire flow, you are in what we call run mode. Why do we have 2 different modes, and what are the differences? In the interactive mode, it uses the caches as you step through the flow. However, run mode runs the flow on actual full set of data. Now, what is happening behind the scene? Let's take input node as an example. When the first time you import your input data to Prep Builder, Prep UI will get that request. Compiler will generate an execution plan to execute a list of queries against your data source. Meanwhile, Prep will fetch the data from your data source, then materialize into our cache database called Hyper. After the first time use, all afterwards usage of your input node will be against our cached database without communicating to your database. This can be much faster because our cache database is local. It avoids network latency. We have cache mechanism for other scenarios as well, such as join and union. Therefore, when you are in interactive mode building your flow, our caching mechanism can be a big factor in terms of performance, which means it is more expensive for you to go back to change steps towards the input node than changing the steps towards the output node, because we will recalculate all caches for all the nodes that is after the changed node.
So there are a lot of factors which can impact performance. Today we're going to talk about 6 of them today. The first one is the amount of data in the flow. So the more data, the longer it will take. There's a pretty big difference between 10,000 rows and 10 million rows. Second, the databases you connect to. Some just tend to be slower than others, and some may not be properly indexed. Sample size. Here we're going to talk about the default sample and how we create it, and why you would opt to change it. We're going to get into some tips and nuances of joins, aggregations, and filters that help with reducing the complexity of the flow, which then helps with performance. The type of output file, be it a TDE or Hyper or CSV, it actually can be a big deal. So we're going to talk about different examples and strategies. And lastly, the importance of the machine specification, where Tableau Prep is actually running. This can actually impact your performance considerably. Now let's get into the amount of data. So when you input the data from your database or file, it brings in all the columns and rows of data. If you bring in a file with 200 columns, it will import all of them into Prep. So the key here for performance is to minimize the amount of data after you have brought it into Prep. You start to look at that data and start reducing the columns you don't need in the input node. Click those fields you will not do analysis or expect your end users to use, and then in essence, removes it from the rest of the flow. Also, a tip I want to share with you that I've learned from customers and some of our internal analysts, if you have a description or comment type of field, and it's filled with large amounts of string text, and you don't plan on analyzing or processing that particular column, it's best to remove those early. Otherwise, you're carrying that column with large strings with you throughout the flow, and that impacts performance. So we already did the first step of removing the fields you aren't using from your flow in the input node. Now, within those fields, can we start shrinking down the amount of data in the rows? So here's a couple ways we can do it. The first is a filter. Filters are great on reducing the amount of data you're processing. You can filter using a calculation, a selected value, wildcard match, or simply removing all the null values. In this example, I've created a filter calculation by setting the state equals to Nebraska. So whereas my state had all of them before that field, now I've narrowed it right down to just Nebraska. Now the second option is to use the keep only field. This will allow you to keep only those values you want for a given field. For example, in my field it's called catalog, and it may have 3 different values of office furniture. It could have patio furniture, dining room furniture, office furniture, and you may want to keep only patio furniture. So this will reduce the amount of values in the field and pare down the number of rows of data to just the ones you selected. Now those are both 2 strategies on removing the amount of data in the rows.
Now I'm going to show you how to remove columns and remove the rows. So if you look at here, I have first an input node that has 10 million rows of data. And then on the right-hand side, this is the list of the columns that it's in this data set. If you know some of the fields that you won't need it, you will just go here and uncheck the boxes. That way, you don't bring this into the later steps, and you can shrink the data set. Another way is, after unchecking all those columns, you can also create a step node, and then you put a filter. So for example, this one, I put a filter here to shrink the numbers of rows of data. The filter that I put is, I'm only interested in the is arrested equals to true. That way, it shrinks, excluding all the data that has the false value for this column. So this is two strategies to reduce your data by excluding the columns and filter down the rows.
So are you bringing in data through the input node and it's taking a while? Now what do we do? So how many of you have experienced this problem? Oh, I see lots of hands. So I'm not alone in this. So here are 5 tips that may help. First, you can connect to Excel files or on your hard drive or on a network share. Now for the fastest performance, we recommend copying remote files locally if possible. It avoids moving the data over the network, which can be costly, especially for large files. Now I recognize that sometimes this may not be an option due to the size of your file, or your admin may want them to stay on the network share for security reasons. Now on a related note, talking about bringing large data files over, when connecting to those large data sets remotely, we recommend using a wired internet connection versus wireless. So you can try it yourself in your environment and see the difference. Most times you will see the wired connection is just faster, and with the large data sets, it makes a big difference. Make sure the database you are pulling from is correctly indexed and performing well. You can work with your database administrator on this if you feel like queries are kind of slow or you feel like they're sluggish. The DBA can help you identify your queries and then make sure they're indexed. This is super important because one of the biggest jobs in prep is pulling the data from the database into prep, and you want to make sure that step is fully optimized. Fourth up, custom SQL is important, but it can cause a problem for prep because it's a black box to our query processor. It's an unknown. This prevents us from being able to optimize for performance. However, we recognize that it may not always be possible for you to do everything in prep, and sometimes custom SQL may be necessary at times. But the tip here, try it in prep first before using custom SQL and see how it performs. See if you can avoid the custom SQL and do all the cleaning and the filtering that you need to do in prep. This might actually give you a performance boost because it allows our query processor to work on those steps that you're performing. Lastly, this tip is very specific to SQL Server. So you can set the database isolation level for SQL Server to read uncommitted. For very large queries, if this is not turned on, it can lead to long-running queries in Tableau Prep, which result in locked database tables and timeouts. So please try it and see if it improves your perf on really long-running queries. By default, Tableau Prep uses sampling to bring only a portion of your data in when you connect to your data sources. This makes the flow more efficient as you are building it out. So when you're creating that flow in an interactive mode, you're using just a subset of the data. But when you run the flow, as Christine mentioned earlier in the architecture overview, when you run the flow and generate an output, Tableau Prep will process all the records in your data set. It won't use just the sample. Now, how do we actually figure out, how do we create that default? So data sets with more fields will result in a sample with fewer rows than data sets with fewer fields. This means if you have 300 fields, you will get fewer rows in the sample than if you had 5 fields. Data type is also a factor. Fields with a string data type are usually larger than a numerical data type. So text-heavy data sets will return a smaller number of rows when sampled than data sets that are predominantly numerical. So prep starts with the default. Now, why would you want to change your sample? We're going to go through 3 instances where you may want to change it. The first reason, you need a more representative sample. So this can happen when you have data that is ordered by date, and when you're pulling that sample, it's only pulling from 1 year. A customer example, this came up maybe a few weeks before TC. They had ordered their date by 2010, 2011, 2012. Now the sample was only taking the data from 2010. So they wanted a more representative sample, so they changed the default and brought in more rows. Now the second reason you may want to change the sample is you just may want to generate more data in your sample. There's too much uniqueness, weirdness, there's irregularities in your data that you want to capture and clean, and the default sample may be too small. Now third, this is a really interesting case. You may want to generate an even smaller sample. Now I want to raise something that I've heard from not only customers, but our internal Tableau data analysts who use prep. They will create a sample size of 1 row. That's right, 1 row. They feel like, I know my data, I just want to build the flow as quick as I can. And in order to do that, I want the minimum amount of data to go through it. Now remember, that's when they're interactively building the flow. When they hit the run, they still run it with all the full data set. So you also have the option to do the random sample. Now this is a more thorough approach of sampling your data, and it may impact performance because of it, and it will take longer to generate that sample. Now we're on to reducing the complexity of the actual flow. Now first up is joins. Joins are the most expensive operation within Prep Builder. Wouldn't you agree, Christine?
Yes.
Joins are expensive.
It's very expensive.
So when making a transformation, consider whether or not you need to see the result in the context of the join UI or not. So you see in this example, everything's being done within the join UI. Now, if you can, add a step node for each input before the join and do some cleaning there, or add a step node after the join and do your post-join cleaning there. This will allow you to work without the performance cost of having to recompute the join or showing the join UI. Now, cross-database joins. Here, I just want to explain a little bit about how the inner workings of Tableau deals with cross-database joins. So, when we are doing a join across 2 different databases, such as in this case, we will force the backend system to use the federation engine, which moves everything from both sides. So in this case, the SQL Server database table and the Teradata database table into Hyper, moving that much data over the network into Hyper. It does the join there. Then we run the queries on that result set. Now, I just want to point out a couple performance, just things to be aware of. This extra data move of moving the data from the SQL and the Teradata into Hyper, it can be costly because you're moving a large amount of data, usually, over the network. Now, one thing I have noticed, if your source database tends to be slow to begin with, moving that data, the one-time cost of moving that data into the database, doing the join there, then all subsequent prep queries will then hit that result set. It's actually faster than you hitting that slow source database yourself. So just some things that I wanted you to be aware of with cross-database joins. Here's one more example. I just wanted to share this because it came up probably a couple months right before TC. Here's an interesting customer example. The SQL database is a huge table, and they're joining it to a rather large Excel file. Both the Excel file and SQL table were originally brought into Hyper and joined, and the result set was used by the prep queries. However, the customer was saying, you know, we're kind of getting inconsistent query performance. We're wondering if there's more we can do on our side. So they took it upon themselves to move that Excel file into a table within their SQL Server database. They did the join there, and they moved the result set over to Hyper. And they actually found that the query performance time was more consistent. And so in essence, they avoided the cross-database join issue. Now, I can't guarantee this will work in all cases, but it's just an example that I thought was interesting and I wanted to share with you all.
So data type also can impact join performance. Here is a test that we've done where we have exactly same field values in two separate flows. In one, we set the type as a string and the other as an int. The result shows that the same flow runs 35 seconds with string comparison, but 6 seconds with int comparison. A lot of our customers join on strings just because that's what they have got. But there might be a way to transform to an int before running the flow, which might have significant performance difference.
So Christine, do you mean that if I can convert it into an int, it'll actually give me faster performance?
Yes. If you can do that,
very cool.
Convert it first.
Very cool.
Yes. As you mentioned, join is the most expensive operations in prep. So moving filters, aggregates before the join, whenever logically possible, should shrink the table and help performance because fewer rows equals to faster processing. So getting stuff out as soon as you can if you know you won't need it later on. So here I'm going to show you a demo of what I mean. So if you look at their two flows, the top one here highlighted, I'm having two input nodes. Each of them have 10 million rows of data. I'm doing cleaning steps first on each of them, and then add a join step afterwards. That way, I'm already shrink the data, input data for the join, and then output to a file. And then the bottom one, I'm using the same exactly two nodes. That's the 10 million rows of data. And then I'm doing the join first. That means I'm taking the entire two nodes with 10 million rows of data to join first together. And then I'm doing the cleaning later. As we know, join is very expensive.
It is.
Yes. So it is actually performs much slower than the top one. I'm not going to run it right now because it takes a while to finish the flow. But that's the recommendation. If you have very large flow that you know you're going to do cleaning afterwards, do it before you do the join.
All right, we're on to the script node. So this is a brand new feature that just came out in 2019.3. So please try it. I think you're going to love it. You can now run Python or R scripts within your prep flow. So the script node runs a script on a separate server and sends the results back to the prep flow. Now, if it's an intensive script, then that may take some time to generate those results. And if it ends up being a large result set, then it could take some time to send the results back to the flow. These are just some things to keep in mind with this step. I have some personal scripts that I run on my laptop. Some of them run in less than 30 seconds, and it takes maybe 200 milliseconds, to get that data. Others take 5-6 minutes to run, but the amount of data they're sending me back isn't very much either. So it just depends on the script and how much data you're receiving. Now, I heard an example from a customer who used the script node in beta, and they did all their work in Python before even using prep, and now they use prep and they use this script set to just run their Python scripts. And they've noticed a 30% improvement in their cleaning time.
Wow, that's a lot.
It's huge.
Yeah.
And so they can do it all with this new script node and our regular prep flow process.
Aggregates can be also interesting. If you know what you want to see the data at higher level of the granularity, please add an aggregate step. For example, you may want to look at sales data at the state level across all US states. However, the data you have, it's at the granularity of county. So we would recommend you add an aggregation step in prep to aggregate it first, and then port that into Tableau desktop, so that it's already cleaned and it's faster. So knowing how you want to see the data is super important for figuring out how to aggregate the data. There are a couple ways that a numeric field can be aggregated into. Their sum, their average or median, their count or count distinct, and minimal or maximal. So here I'm going to show you a demo of aggregate. So if you look at this flow, the input data I'm having, I'm using a wildcard, so it has 6 different files here, and each file representing one state. And then here, the data I have, it's at the granularity of county level. And now, if I'm only interested, I don't care which state, I'm only interested into the group of driver races, so I can just drag this group to the group field. And Tableau does the grouping for you. And here's the result, which is the aggregated result. And then you can just add that as an output node and output this result. That's shrink your data a lot. Now we talked about input nodes, step nodes. What about output? So output type is also another factor that could impact performance. Currently, there are 3 file types that you can choose from your output node: CSV, TDE, and Hyper. Here, I created a simple flow with 2 input nodes, a join step, then an output node. Each input node has 10 million rows of data. The only difference are the output type. I trigger the flow in run mode. From the result, you can see Hyper runs 11 minutes, TDE runs 19 minutes, and CSV runs 2 hours and 47 minutes.
I actually asked Christine, because I saw those numbers, and Christine's the expert in perf and scalability and testing. I asked her, I said, this has got to be wrong. Please rerun this, because these numbers just seemed crazy. But she did, and she came up with these numbers consistently. So
yeah.
I was pretty surprised.
Yeah, so that tells us, if you are dealing with very large extracts, please use Hyper. Besides reducing complexity of the flow that we already talked about, machine spec is also something you need to be aware of, as it also can impact performance significantly. For example, if you have antivirus or indexer software that can scan your files periodically, which could slow down your flow run. Here's the recommendation. If you can, configure your data directory and flow directory and output directory to be excluded from those scanning and indexing. Second, if you find a flow that is slower in certain machine, please check the memory of the machine. If you have very low memory machine, we will do a lot of swapping in and out, which will cause slowness. The third one is if you have a low disk. Low disk machine will result in very instability result. And sometimes the flow won't even be able to run. Now you have finished your flow building exercise. And if you just want to get regular extract refresh for a particular flow and without changing any steps, we have a very convenient tool for you to use. It's called command line interface. Why do I want to use it? Because you can directly run the flow without open the Prep Builder UI. That saves you a tons of time. And also you can schedule it through command line. You can put that command into a script and then integrate that with the Windows task scheduler so that you can run at any time, at any regular cadence that you want. Oh, that's cool, right? So how can I use the command line? So currently, command line is supporting Mac terminal and Windows command, which also integrated with Windows task scheduler. And all you need is administrator privilege on the machine that you're gonna run the command line. You know the path where Tableau Prep Builder is installed, and you know where is the flow file that you want to run. And if you have remote connection to any input data source, or you need to output to a remote server or online, you need a credential JSON file. And that's it. And then here's the usage of how to run the command line. You basically just go to where Tableau Prep Builder is installed, and then go into the and then type in Tableau-prep-CLI with corresponding options, and hit enter. That's it. And the flow run. And this is the end of our presentation.
Are there any questions? Okay, great. Thank you.
Thank you.